Good afternoon, all of you. So, in redox reactions, we were dealing with electron transfer reactions. So, how redox reactions are carried out through electron transfer? That's what we were discussing. And we completed few examples also. So, today we will be discussing about competitive electron transfer reactions. So, what is the difference between an exam and a competitive exam? A usual exam, it can be done for self-evaluation also. But a competitive exam means there is involvement of a competition. And one more difference is that a usual exam can be carried out with just one person or it can be conducted just for a single person. But competitive exam cannot be conducted for single person. There should be a competition or at least there should be two contestants to write the exam. Then only there is a competition. So similarly, we will study what is competitive electron transfer reaction. Yesterday we have seen such reactions where one of them was an electropositive element, another was an electronegative element. So the metal or the electropositive one will lose its electrons and that will be accepted by the electronegative atom, which is chlorine here, and gets reduced by itself. So that was a usual process. In that, sodium was electropositive and chlorine was electronegative. There is no confusion or we don't need a second thought about which of them will give the electrons out or which one will be the donor and which one will be the acceptor. We don't have any doubt because one is a metal and one is a non-metal. So the electropositive metals only will donate electrons. That was a non-fact, so there was no competition. But if there are two metals present, then there is competition or both of the metals will have tendency to lose electrons and in that case the stronger one wins the race. We will see an example. This example we have seen yesterday also. So in this case zinc is a metal and copper is also a metal. One of the metal is a donor here and the other one is an acceptor even though both of them having tendency to lose electrons. So both are metals, both are having tendency to lose electrons, still the stronger one will give out electrons and the weaker one is accepting it. Yesterday when we spoke about the redox reaction, we told the zinc is the one who gives out electrons to copper and substitutes the position of copper in copper sulfate. It forms zinc sulfate solution and copper is being given out. So we can tell it's a displacement reaction also, where the zinc is displacing the position of copper in copper sulfate and forming zinc sulfate. So reduction is for the copper, accepting electrons from zinc, the copper is getting reduced to form Cu metal. We will see this experimentally for better understanding. First, we need to prepare a copper sulfate solution. So copper sulfate solution is blue in color. And now we are introducing a piece of zinc to the solution. So we are adding a piece of zinc metal to the solution. So there it starts this reaction. So once the zinc metal is added to the copper sulfate solution, this reaction will start, which is the zinc, which is the stronger one here, will donate its two electrons to copper and substitutes its position in the reaction. So from copper sulfate, copper is being removed as Cu solid and zinc solid is converted to Zn2 plus ion and it goes to the solution and forms ZnSO4. So the changes Cu was Cu2 plus ion and the ion is being converted to Cu metal or solid. And when this reaction happens, slowly and slowly the color of the solution diminishes or the blue color of the solution diminishes. And why is that so? So that is because the color of the solution or the blue color of copper sulfate solution is due to the presence of Cu2 plus ions. So this Cu2 plus ion is responsible for the color of this solution. And when the Cu2 plus ion is only converted to Cu metal, then what remains is ZnSO4. And ZnSO4 is a colorless solution. So from CuSO4, the reason for color is Cu. and that Cu is substituted by zinc, then the color will not be there anymore. So slowly and slowly, as zinc is substituted with Cu, this process is a slow one. So initially when we add zinc only, all the zinc is not substituting Cu. So slowly only this process happens. So slowly and slowly, the zinc is substituting the copper. And as CuSO4 is converted to ZnSO4, leaving the Cu metal, the color of the solution diminishes, and finally it will become a clear solution, and the Cu, the solid Cu, which is converted from Cu2 plus to Cu0, the Cu metal will be deposited in the zinc rod. So slowly and slowly, the Cu will be deposited in the solution as a black color, and the color of the solution, the blue color of the solution, will change to a clear one. So concluding, this is the reaction between the metals which are present here. This is why we told it's a competitive electron transfer. There is actually competition between zinc and copper to donate electrons. Both are capable of donating electrons, but the stronger one will win the race. So here, while comparing zinc and copper, zinc will have more ability to donate electrons. So that is why zinc donates its electrons to Cu and becomes oxidized, and copper accepts the electrons from zinc as it is the weaker one and undergo reduction. So now the question is, will we be able to reverse the reaction? Here we have taken copper sulfate solution and introduced a piece of zinc metal. And if we try to add a piece of copper metal to zinc sulfate solution, will the copper be able to substitute zinc and forms copper sulfate and zinc? It's not possible. The reverse of this reaction is not possible because, as we told, zinc is actually having more capability to donate electrons than that of Cu. So if copper tries to attack ZnSO4 or try to donate its 2 electrons to zinc and substitute zinc in this position, it is not possible because zinc is already having much ability than copper to donate electrons. So when this is more able to donate electrons, why should this accept an electrons from copper? So zinc will not accept electrons from copper as it is a stronger one. So substituting zinc in zinc sulfate solution is not a task for copper. So that's why this reverse reaction is not possible. So copper with ZnSO4 will not give CuSO4 and zinc metal. We have seen this reaction just now. So in between zinc and copper, zinc was the winner in the competition. Zinc was able to donate electrons to copper and wins the race. If we consider another reaction, copper and silver we are taking. We are taking a silver complex and copper. So in this, if you see, copper is able to donate electrons and Ag or silver is accepting the 2 electrons. So here the winner is copper, right? So all this is because of their ability to donate electrons. In this case, copper is having more ability to donate electrons than that of silver. So if we try to take a compound of Ag, for example if we take AgNO3 and add Cu metal to it, what happens is it will get a blue color and Ag metal or silver metal will be deposited. So just opposite of what has happened in this case. So here we have taken a complex of Ag or a compound of Ag and adding Cu metal to it. So in this case, Cu is able to substitute Ag in the complex by releasing 2 electrons to it. So in this case, Cu is giving out electrons to silver and forming silver metal. So once Cu2 plus is in the solution, it is getting a blue color. So Cu2 plus from Cu solid or Cu0 is converted to Cu2 plus, and this Cu2 plus is giving color to the solution, and the one which was in the solution, which is Ag plus, and that Ag plus is converted to Ag by getting 2 electrons, and that Ag solid is deposited in this solution. So this is the reaction which is carried out here. Copper, when added with AgNO3, the Ag is accepting electrons from copper and converted to Ag solid. So here Cu is the reducing agent which releases 2 electrons to Ag and converts or reduces the Ag to form Ag solid. And copper is getting oxidized by giving out the electrons and forming Cu2 plus ions with CuNO3. So in this case, zinc was having more ability to donate electrons and copper was accepting from it. But in this case, when we compare copper and silver, copper was having more ability than silver to donate electrons. In this case, if you see, it is between cobalt and nickel. So cobalt and nickel, the solution if we take of this reaction, the nickel 2 plus ions and copper 2 plus cobalt 2 plus ions will be in same quantity. So nickel and cobalt is having same ability to donate electrons, and that's why these reaction will be in an equilibrium. So this is a kind of reaction where we get nickel and cobalt ions in the same level. So as they are equally strong, they will have an equilibrium between each other. So by comparison, we have come to know that zinc releases electrons to copper and copper releases electrons to silver. Therefore, the electron releasing ability or electron releasing tendency of these metals are in the order: zinc will have more tendency than that of copper and copper will have more tendency than that of silver. So that is the order for releasing electrons. And when we are doing redox reaction, how will we understand that this one is stronger and this one is weaker, or how can we compare all of them? So for that we do have a list of elements which are known as the electrochemical series. So this series tells us which one is having more ability to donate electrons and which one is having less ability to donate electrons, and this is the order. So the elements which we have taken are zinc, copper and silver. So if you see the order, you can understand zinc is having more ability to donate electrons than copper than that of silver. So silver is in the last row and copper is above it and zinc is more above it. So zinc is having more ability than that of copper than that of silver. And this list is known as the electrochemical series, and you don't need to write this on your notebook, you just need to understand what is an electrochemical series. So with this we complete our competitive electron transfer. So prepare notes and submit. Thank you.